All right, so on the quiz, we'll start out with a first question. We started out on the first homework, and your test and your semester test will all have this same question on it. Okay? So, coterminal angles. What's coterminal with an 18-degree angle? How far do we go? 360 degrees. So, what's 360 degrees more than 18? 378. What's 316 degrees less than 18? So 18 minus 360. Negative 342. Okay? So coterminal angles are 360 degrees apart. Now, are these coterminal angles? Well, we know they're not 360 degrees apart. Okay? So coterminal angles are 360 degrees apart, or 720 degrees apart, or 1080 apart, multiples of 360. So, how far apart are these two? How far apart are those two angles? So you take 315.6 minus a negative 764.4. What do you get? 1080, coterminal. Okay? So if they're 360 degrees apart or a multiple of 360 degrees apart, then they're coterminal. Okay, 109-degree angle. Well, if this, I can't believe it keeps doing that. Quit doing that. If this is 90 degrees, 109 would be just past 90 degrees, right? What quadrant am I in? 2. It's the Roman numeral 2. So that's 2 i's. 3 is 3 i's. 4 is IV. Okay. All right. Convert to decimal degree when it's in degrees, minutes, seconds. Well, do you multiply by 60 or divide by 60 when you're changing minutes into decimals? Divide by 60. So this is 39 point what? What's 51 divided by 60? What? 0.85. Okay. All right. The next one, negative 70.534. The first box is negative 70. Okay. You don't worry about the negative anymore. Then you take 0.534. And here we divided by 60. So here when we're going to degrees, minutes, seconds, we're going to multiply it by 60. What's 0.534 times 60? 30 what? 32.04. So you go 32 and then you take 0.04 times 60. If you take 0.04 times 60, you get 2.4, correct? Well, if you rounded to the nearest second, it would be 2. So negative 70 degrees, 32 minutes, 2 seconds. Okay, converting to radian measure. When you're going to radian measure, you're multiplying times the radians, which is pi, divided by the degrees, which is 180. Because in a full circle, there's 2 pi radians and 360 degrees. So we just go half a circle so the numbers aren't so big. Okay? So if we divide that, I divide them both by 10. It's 33 over 18. 3 goes into each. So it's going to be 11 pi over 6. 11 pi over 6. Okay. We good with that? All right. Convert to radian measure. Still doing the same thing. Multiply by pi, divide by 180. 45 goes into 180 4 times, so it's pi over 4. When we're converting from radians to degrees, instead of multiplying by pi over 180, we multiply by what over what? 180 over pi. We just flip the fraction over. Okay, just flip the fraction over. We eat our pies, they cancel. 5 goes into 180 36 times, right? So it's 6 times 36 or 216 degrees. Okay, we're going back to converting to radians. So we're going to multiply by pi, divide by 180. And this one time, we want to use integer or decimal. Okay, so we want you to use your calculator. Take 79.5 times, press the pi button on your calculator, and then divide by 180. So do that both. So you multiply by pi, divide by 180, and round to the nearest thousandth, which is 3 decimal places. So what is it to 3 decimal places? 1.388 radians. Sounds good to me. That should be about right. No. Wait, just let me think. Yeah, that's right. Which angles are coterminal with pi over 3? When you have a fraction, okay, you need a common denominator to add and subtract fractions. Because when you're dealing with radians, how many radians are in a full circle? 2 pi, okay? Because coterminal angles are 360 degrees apart, which are a full circle. So then if it is a radian measure, we have to add 2 pi to it. So it's pi over 3 plus 2 pi. But we can't add these because we don't have a common denominator. So we have to switch 2 pi into what? What over 3 is 2? 6. 6 over 3 is 2. So you're adding 6 pi over 3. So 1 pi over 3, you get 7 pi over 3. Okay, that's one answer. So then you have 7 pi over 3, and then you're going to add another 6 pi over 3 because you have to go around again. And you get 13 pi over 3. Okay, so 7 and 13, the only answers with 7 and 13 are in, both 7 and 13 in it, is choice D. The quadrant where 4 pi over 5 is. For some people, they know radians pretty well and they know how to work with fractions. Other people just say, well, let me change this into degrees because I know where they are in degrees. So to change it into degrees, we multiply by 180 over pi. Pi's cancel, so it's 4/5 of 180, or 4 times 36. 4 times 36 is 144. 144 degrees is in what quadrant? 90, 180, 144 is in between there, so it's quadrant 2. Arc length. Well, the arc length formula is on the board. This angle, is it in degrees or radians? Radians. There's no degree mark, is there? Okay, no degree mark. Mr. Johnson can't see that from way back there, even though he has glasses. All right, so if we're in radians, we use the trig formula. All we have to do is multiply our angle times our radius. So we take, to find arc length, it's the angle, 4.6, times the radius, 118. If we multiply those two, what do we get to the nearest tenth? 542.8. Okay, that's the arc length. Now, if we're given the arc length and we want the angle, or we want the radius, okay, we have to work backwards. We say 19 equals, oh, we're in degrees here, aren't we? So I got to scrap the trig formula and use the geometry formula. X over 360 times 2 pi r. So it's x over 360 times, x is 162, times 2 pi r. Okay, so I got to get r alone somehow. Okay, got to get r by itself. So what I would do is I would do it one step at a time. So I'd multiply by 360. Those cancel. What's 360 times 19? Somebody with a calculadora, por favor. 6,840 equals 162 times 2 times pi times r. Just to be careful, I'm going to divide them one at a time. So I'm going to divide by 162. What's 6840 divided by 162? And then divide that by 2. Don't clear out your calculator. Divide it by 2. And then divide by pi. So 6.72 kilometers rounded to the nearest hundredth. Rounded to the nearest hundredth. Okay. Find the exact area of the sector. This is in terms of radians. So you're going to use the trig formula. So sector area equals the angle times the radius squared divided by 2. So the angle, pi over 3, times 18 squared divided by 2. So it's pi over 3 times 18 squared. I know 16 times 16 is 256. So 18 times 18 is like 324. Divided by 2. I know 324 divided by 2 is 162. 162 divided by 3, I know 3 goes in there. 54 times. So the area is 54 pi. Type an exact answer using pi as needed. Yeah, so you don't press the pi button on your calculator when you're doing this, because they want it in terms of pi. Okay, then we're doing unit ratios. Minutes cancel with minutes. Radians cancel with radians. So I'm going to have revolutions per hour. 2 times 60 is 120. Divided by 2 pi is the 120 and 2 divided by 60 divided by pi. So in your calculator, take 60 divided by pi, because I can cancel them right here. 60 divided by pi is 18 point something. 19.1. Rounded to the nearest tenth revolutions per hour. A windmill for generating electricity has a blade 30 feet long. Depending on the wind, it rotates at various velocities. Find the angular velocity in radians per second for the tip of the blade if the windmill is rotating at a rate of 100 revolutions per second. Now, I start out with 100 revolutions per second. If I'm changing it into radians, how do I get rid of revolutions and get to radians? 2 pi radians over 1 revolution. The revolutions cancel. Now I have radians per second. Hey, I didn't use my 30 feet long. Shouldn't I have used that? Not with angular velocity. That's linear velocity. So you don't use the 30 feet long in this problem. So multiplying that out, 2 times 100 is 200. 200 times pi is 628.3. Yeah, 628.3 radians per second. Now, here, the saw blade problem, you start out with 3850 revolutions per minute. We need to get rid of revolutions. To get rid of revolutions, we multiply by 2 pi radians over 1 revolution. Revolutions cancel. Radians per minute. So now I got radians. Now I want the radius of the blade so I can get eventually to miles. So if it's a 15-inch diameter blade, what is the radius of the blade? 7.5 inches per 1 radian. Radians cancel. So now I have inches per minute. Now I need to get miles per hour. How many inches are in a foot? 12 inches in 1 foot. How many feet in a mile? 5,280 feet in a mile. Feet cancels the feet. Inches cancel with minutes. I have miles per minute. Now I need miles per hour. There are 60 minutes in 1 hour. Minutes cancels the minutes. Now I have miles per hour. So you take this number times this number times this number times this number. Press equals. Divide by 12. Press equals. Divide by 5280. Press equals. And we should get miles per hour. And since that's going 3850, it's going pretty fast. I would think it's over 100 miles an hour, but I'm not sure. "15-inch diameter blade, that's pretty good diameter too. So yeah, it's got to be going over 100. 171.8 miles per hour. That saw blade's going fast. All right. Finally, a printing press has a roller 12 inches in diameter. A speed on the roller surface is 59 feet per second. We want to get it to radians per second. So I want to get it down to the radius, but we have 12 inches in diameter. So that's a 6-inch radius. So if we have a 6-inch radius and I'm in feet, I need to convert my feet to inches. What am I going to multiply to convert feet to inches? Is it going to be 12 inches over 1 foot or 1 foot over 12 inches? 12 inches over 1 foot because feet is on top. Okay? And then I want to convert to the radius. So 1 radius is 6 inches. Radius cancels, so now I'm in radians. So 59 feet per second times 12 divided by 6 is 118 radians per second, right? So we're good. So that's the types of questions that you'll see on your quiz. Okay. I am gone on Thursday. So you'll have your quiz Thursday, and I want to move on to the next section. So I got a little preview lesson today. So at about 5, well, maybe 10 to, so I'll give you 40 minutes to do the practice quiz here a couple times. And then at about 10 to 11, we're going to start on the next section with a 2-problem assignment. But your 2-problem assignment is really like a 12-problem assignment because each problem has 6 parts. So that's what we'll do. So let me get out your assignment and then we'll get going.